Hello everyone, welcome back to my channel. In this video we are going to cover how to study drawing for ABB ACS 850. So we have almost 15 pages here, starting from page number 3 till page number 17. Few pages are not of use, so I would recommend you guys can watch this video on 1.25x, and this video is going to be a bit lengthy, so bear with it. And I hope at the end of the video you will get to know how to study this drawing or any other drawing. So without further ado, let's get started. So here the title is there, or every page will have a title. This is a single line diagram for ABB ACS 850. We'll start with the left hand side. Here, as you can see, these are indicators on the panels: R phase, Y phase, B phase. When the main supply is switched on, the case drive is not running, only the panel has got the supply, so you will see all these lights glowing. How it will glow? It will come here and check. Later on, there is an indication for drive ready, that is H1, drive run, drive trip. These are all indications. This is VAF meter, that is voltage, frequency, voltage, ampere and frequency meter. This is motor current, analog meter, 0 to the maximum rated current. Next is SW3, that is LCB DCS selector switch. That will be available on the panel, local and DCS selector switch. Next is emergency switch for the panel. Emergency switch will be on the panel and on the field. We'll see in the video, like in the drawing ahead. This side, okay, this is temperature scanner. In India we rarely use. If required you can use it. And this one is C1, that is ACS CP control panel, or you can say CDP or HMI. So this is connected to the drive with the help of a cable. And we'll come to the central part. This is 415 volt AC plus minus 10% tolerance and 50 Hz. In India we are using 50 Hz. Abroad, China, Japan and USA, they use 60 Hz plus minus 3% main supply. So here the main supply will come, and before coming to this part, we can see the right hand side because this is interlinked. We'll see the rightmost part. Here it is 3-pole MPCB, okay, and the rating is 4 amps. It is the MPCB switch, and this is 415, all the 3 phases. And here we have a control transformer, 415 to 230 volt and 110 volt. So it will convert into 2 voltages, and the rating is 1000 VA, that is 1 kVA. After control transformer we have MCBs, two pole, all are 2 pole, and the rating is 6 amps, 2 amps and all these things you can see. So 415 volt is converted into 110 volt control supply. 110 it is. 230 is here AC supply. It is for lighting and panel heating. Panel heating is rarely used because the drive is already so much heated when it is in operation. Again 110 volt for temperature scanner. If required we can use it, if not skip this part. And 110 volt for LCS. So this is important. This is important, and a part of this, because lighting of the panel is important. This can be skipped. Now we'll come to the central part. Here we have 3-pole MPCB Q7. These notations are very important: Q7, F10, here F15, okay. And from Q7, see, once we get the supply, once ACB is on, here we'll get the supply and the indicating lamps RYB, all these 3 will glow. This has nothing to do with the drive running condition. Once it gets a supply, it will show, okay, the panel is getting the supply. Same MCB is connected with VF meter. It is here. And next, it is connected to CTs. So these are 3 lines, RYB, and it will go and feed VAF meter. So for current, it will check the ratings from here. We'll see it ahead. And Q1 is very important, that is main MCCB, molded case circuit breaker, 1000 amps here, because the current is quite high for this particular case, that is 875 amps. So once we switch it on, current will come here. This is CT for all the 3 lines. CT for all the 3 lines. RYB rating is available 1000/5. It will change, the rating will change according to the drive rating. Then we have fuses Q4 to Q6, And this is SC fuse, that is semiconductor fuse. The interview they can ask what is the full form of SC. And next is our drive. It will convert AC to DC, and again it will convert back to the AC, modulating AC you can say. And this is the output choke. So why chokes are required in the drive? There is a separate video for that. I will put the link in the description, you can go and check it. And the rating, why it is rated like drive is rated like ACS 850, 04, 875 and 5. So what all these parameters mean, there is also a separate video on that. I'll put the link for this one also. And I had K1, that's a output contactor. This is the main drive output contactor. Like once we get the supply through this and we are getting supply through till here, the K1 gets pick up and it will feed the motor, and the motor will run on the desired speed. So this part is completed. We'll move to the next part. Linking the pages is very important, and you will get to know. I'll give you one example here how we link like one page to another. That is very important. So this is the second page number 4. Okay, so to measure the voltage, that is Q7 was available, right? If you'll go and check the last previous page, you will find Q7. See, Q7 is here. So once Q7 is pressed, it will go to VF meter. See, Q7 is on, it will go to VF meter to measure voltage. This is the main supply, 415 volt. Again, for control supply, we are getting the tapping here. Okay, for example, if you want to see how it has been done, so here you can see 6.A1. So this is 6. Okay, we'll check in the next page. This is control supply. Next, MCCB from the previous page, Q1, this one. This one. Once it has been on, okay, the camera is not steady, you can skip it. And once it has been on, all the phases are provided with CT, current transformer here. CT1, CT3, CT1, 2 and 3. So it will again go and feed to VF meter to measure the current. That's how it will measure the current. Okay. So this part is being done, and again it will go ahead. Okay. Next, here we can see how the drawings are connected. So these 3 lines is gone to page number 5, A and A2. I'll write it here, 5.A2. So 5 means page number 5. Like here it is 4, no? Next is 5. This is 5. And A and 2. What is A and 2? See, likewise it is 4.A2, no? Here it is written. See, 4.A8. Though this is the very tricky part. If you are new to the drawing, no, this is very important. I'll just help you let you understand. So 5, it will go to page number 5. This is page number 5. This is A. This is A. This complete section is A. Okay. And next is 2. So we'll come to this part, till complete section, and this is the second part 2. Okay. So you can see all these things will fall under this part, and similarly 4.A8. So this is page number 4. This is A again, and this is 8. So that's how pages are linked from one page to another. We'll come to the 5th page. Again, all these 3 lines will come. I'll explain this once again in the control drawing because that is important. So here you can see this fuses. It will feed to all the 3 semiconductor fuse. It will come back to the drive, U1, V1, W1, and the output is U2, V2, W2. And it will go to choke, output choke. In Siemens drive, there are also input chokes for better working on harmonics, reducing harmonics. And finally, this is output contactor K1. Once it will pick up, it will feed to the motor. Okay. So the power distribution is completed. We'll come to the control part, like control transformer part. See, here you can see how it is when Q1 is pressed. What is Q1? And to understand that, we'll go to this page number. It's written 4.B3. So we have to go to page number 4. This is page number 4, B and 3. So this is complete B and 3 here. So see, this is Q1, Q1. Okay. From there we are taking 2 tapping for control transformer. B and 3. This part. Okay. Not that part. Now it is B and 3. I think there is some mistake because here they are taking the transformer supply. Okay. B and 3. This is control transformer. This is the control transformer. It has to be B6. This one. And from the control transformer we are getting the supply to 230 volt here. Okay. And similarly 110 volt is coming from this part and this part. So this is the 110 volt. This is 230, it is mentioned 110. F15, see F15 is here, F15 110 volt, and again one more to this part. Okay, that is again 110 volt, and that is being used in page number 12. This is used in page number 17, and F15, it is important. It will go and feed to page number 7. So this is very important, these two things. So we'll go to page number 7, that is next page. And guys, this is very important. This is the control drawing now. So this is very important. Be focused. 7.A1. So this is page number 7. This part is A and this is 1. Correct? Similarly, 6.E3. So this is page number 6. This part is E and this part is 3. So here and here. So this part is directly feeding to this part. These two part. Similarly 6E3, 6E and 3, 7E, A1 and E1. This is the difference. This is A1. A1 means this point 110 and this is neutral. Okay, so this is 110 is here, 110 volt, and this is neutral. Hope you got to know how to link the pages. Okay. So this page is very important. We'll start from the very beginning. Okay. So this is 110 volt and this is the 0 part. Once this F15 is switched on, we'll get the supply till here. That means supply till here. And 110 will come here. And this is X51. X51 1. And where it is X51? So this is page number 14.C2. We'll go to page number 14.C2 for better understanding of terminals. So this is 14. This is C and this is 2. X51 1 and 2. Okay. That's how it is connected. X51 panel drive. X51 1 and 2. 7 B2. Page number 7 B and 2. So this is emergency stop LCB. That will go to local supply. See, it is local control board. It will go to the local control board. Okay. So 110, once in the field, if emergency button is not pressed, it will remain NC because emergencies are kept in NC position, normally closed. So 110 will get here. And again, this is external interlock. If you need any external interlock, you can put it here. If not, you can just put a loop. That is X52 1 and 2. Now what is X52? Again, we will better check it because this is the most important piece. And piece number 16 C1. Here it is written 16.C1. So this is page number 16. This is C and this is 1. C, external interlock. You can just put a loop here if it is not required. Okay. We'll come to this point, that is 110 will be here, 110 volt. And this is the emergency stop button of the panel. So it will normally be in NC condition. So 110 volt is here and that is K15. So K15 is a auxiliary contactor for emergency stop. So once everything is okay, this will pick. So K15 is high, and since K15 is high, see here, the terminals or the contact for this contactor, NO NC will be there for auxiliary contactor. Once it is high, this key 15 will get NC. So 110 volt will come till here. Okay, this is interlink. When it is in off condition, it will remain open. When it's get high energized, that will become NC. And next is R13, and R13 is page number 10.D3. So this is page number 10. This is D and this is 3. So this point D and 3, R13, which is relay number 13. Wait. R13, R13, R13. Oh, sorry, this is page number 9. Yeah, this is page number 10. And what is what? D and 3. This is D and this is 3. Okay, R13 is here. So this command, no, this is coming from panel, from the panel. Here you can see. So it will get high, all these three will get energized once the command will come from the drive. So in this condition, this will get high or low as per the settings in the panel. Okay, so this has to remain NC, no? So that means that R13 should not get high, and for that we'll have to go to page number 9, because here it is written 9.F4. This is 9.F4, 9 F and 4. Here it is. So this should remain in open condition, that there is a small relay inside this, that is K1, K2, K3. This is internal, drive's internal relay, and that works on plus 24 volt. So in case the drive is in fault condition or it is not in fault condition, that is decided by the panel setting. If you will go through the setting now, that video is also available in the playlist. So there you can see, you can select this as setting as fault or fault minus, and here it should remain open. Okay, so since it will remain open, it will not get supply. That 110 volt won't come here, and this R13 won't pick. So if it won't pick, then 110 volt will come till this point, and later on it get distributed in two parts. This part is selected by this LCB DCS switch we have seen in the first page. So first select this part, the left part. Suppose we have selected on the left part LCB part. So supply will come till this point, all this point. This is X51, as we have seen X51 is LCB, and all this point we have 110 volt. We start with this one. This is LCB decrease. So to decrease the speed, we have to press, keep this push button pressed, so that it will keep generating that volt, keep generating this R17 relay high, and the speed will decrease. Similarly, LCB increase, we have to press this so that the speed of the drive keep on increasing. How it is connected, we'll see in the drawing. Okay, we'll just check it in the drawing. R17, no? See, R17 here, 7.E2. Where it is coming from? 7.E2. This is page number 7. Okay. So once we keep press, so this 24 volt will come here, R17, and it will go and give the command to drive that speed should decrease. Similarly, R18, the speed should increase. Both are same function, but there is one important information here. You can see R18 is connected here, and R17, that one of the terminal is taken here, so that both cannot work together. This is called interlock. Either this will work or this will work. Both cannot work. Okay, so that's how interlock is provided. Next, we'll come to this part, X51556. That is the emergency stop button, not emergency button. It's a stop button. See, stop LCB. 51, 5 and 6. We'll confirm it on the back. Page number 14. Yeah. Page number 14, and see, start button and stop button. This is emergency stop and this is normal stop button. Okay. So normally it will remain in closed condition. We are using NC here and it will come here. This is start button, LCB start button. So once press it, so 110 volt from here it will come till here, and once this button is pressed it will come till here and it will pick R19 relay. R19, and once R19 is picked, here you can see one of the terminal is being used, NONC contact, R19 relay. So again, once pressed it will come back to its original position, that is it will remain open, but for a fraction of time 110 volt will come here, and later on just it will get the supply, this will get NC, and 110 will come from this point. 110 will travel like this and it will remain open. There is no use. In case you have to stop it, we'll just press it once, that's push button. Okay, so as soon as this push button is pressed, so the continuity of the supply will go and it will stop once the drive is running in local condition. Again we can see the interlock, R19 is used here and R20 is used here, so that both local and DCS cannot work together. That how local system works. Will come to the DCS part. So 110 volt will come here, and this is the command coming from control room. Start stop from DCS 16C2. You can cross check it. 16 D and 2 C. Start stop from DCS to drive. This will give a command that you can see in the RIO panel. Okay, once this has been done, so K15 is being used here again. See, both are in the same condition. Once it will get supply K15, this will become NC, and again this will also become NC, and once then supply will come here and it will go and pick up output contactor, that is the main contactor. It will get high. The main contactor, whenever you will switch on the panel, no, you will get a sound like dhup kind of sound. That means main contactor has been picked up, output contactor K1. So this is the control unit, that's drive control unit, JCU card. Okay, for ACS880 it is BCU, I think. For 800, for 850 it is J series control unit. This is how all connected. Safe torque off, many time you will get the safe torque off fault, so you can just check this and just check the tightness of this point, that's all. And if the drive is running from remote, that is reference from DCS 4 to 20 milliamps. Why 4 to 20? There is also a separate video on this. Why not 0 to 20 milliamps? So there you can go to see. And X52 7 and 8, page number 16, already you know. So it will feed on analog input 1 or analog input 2, whatever is required. You can change it, and you have to change, if you change this, you have to change the setting in parameters also. And this is a very important jumper. Whether you are running with current or voltage, this is current, this is voltage part. So since it is selected here, A1 and jumper is here, so that it will run in analog input 1 with current reference. These are feedbacks. This will go back to PLC. Okay, this is coming from PLC. First one is output 1, how much current the drive is taking and how much speed the drive is running. So this is analog input 1, analog input 2. Now we'll come to this point. This is important again. This is 24 volt. The drive will generate, the drive control unit of the drive will generate 24 volt, and it will come like this. And here it is start and stop, R20 or R19, page number 7. We'll go to page number 7. This is very important. So which is high, R19 or R20? So if R19 is high, it is running from LCS, R20 is high, it is running from DCS. So if any two of them is high, the drive will get a start command. Okay, this is external fault. If required, you can use it. Okay, if not, we can just skip this part. Next, this one is R20, speed increase decrease we have seen. This is external selection, R20. So if it is high or low, it will give the drive will get to know it is running from local or remote. Okay, so if R20 is high, that means if it is high, that means it is coming from DCS. 24 volt. 24 volt is important. See, drive is very complex, very delicate part, so it works on 24 volt. Similarly, if speed increase and decrease, you have no 24 volt come here and here. Key 15, key 15 is high. Key 15, that means everything is in condition. Okay, everything is okay. It will give the command, high command, and K1. So both has to high. K1 output contactor. Okay. Actually, I think only one of them can do it. K1 only can done, but just for better safety, they have taken both because K1 is also dependent on key 15, and there is a loop, that is a start interlock loop, is provided. So that's how it has been done. You got to know all this point also. Drive ready. If the drive is in ready condition, if there is no fault, this one is get high and it will give feedback to there, this point, and this is on page number 10. That is this. Drive R11 relay will get high, and R11 where we are using it, R11 is being used initially on the very first page. If R11 will get high, this will be in high condition, like this will glow, this indicating lamp, and similarly for both this. Okay, these are coming from panel, and this is what, this from here it will go to that point. This is all internal. Here you can see 24 volt, like it will work on 24 volt. Internal release R01, R02, R03. All these three settings can be changed according to the requirement, and if you go to the parameters, you will get to know. So these were the most important pages of the drawing. You got to know all these things, when it will get high and low. This is speed signal, current signal. These are isolators. It will come from drive, okay, and it will give two output. One will go to RIO, and say this will go to RIO, that is DCS, and this will go to field if required. But for RIO it is required. Similarly for current signal. These are can open adapter. If required, you can use it. If not, we can skip this part. These are temperature scanners. If required, use it. If not, you can skip it. VF meter, you got to know how this calculate the current voltage and all these things. And these are, see, R11, R12, R13. So that's how once it is high, it will get supply and it will glow. And this we have already seen. Which all are required, no? For LCS control, local control box, LCB, X51, 1 and 2 and all these things you can get to know. This is local control box R11, R12, R13. Okay. Again, in the drawing you can see like 10.D1, is number 10. D1. See, drive ready, drive. So it will give command to the local box that drive is in remote condition, running or trip condition. Here it was for the panel. Here it was with the panel, this page. And this will go and feed to the local control box, indicating lamps, 110 volt. Next is X52, what we have seen earlier, input command, and this is reference output, drive running trip condition. This will again 11, 12, 13, it will go and feed to the PLC. That drive is in ready condition, on condition, running condition, or in trip condition. DC is selected, it will again go back to the panel, temperature alarm if required. If not, we can skip this part. This is illuminating lamp and all, you can just check it. This is not that much important. And that's how we have completed this thing. I hope if there is any problem, if there is any confusion, feel free to drop a comment. I'll surely reply to that. And just try to understand how these pages are interlocked, how these pages are connected from one to another. That's how it will become very easy to understand any drawing. So thank you guys for watching.